This is the third video for representing networks. In this video, we're going to talk about the degree of a link and look at some relationships between link and nodes. And we're going to define what we mean by the line graph of a network. In the previous video, we discussed the link adjacency matrix for a network. So we were talking about what it means for a link to be adjacent to another matrix. And we obtain the link adjacency matrix by using the incidence matrix and its transpose. We found that product minus twice the identity to obtain a matrix that would give us the adjacency for each link. Well, if we can talk about link adjacency, then that means it makes sense to talk about the degree of a link. So what is the degree of a link? If we look at link F, we see that F is adjacent to links B, C, and G, and also to links E, I, and H. So since F is adjacent to 6 additional links, we'll say the degree of link F is 6. Now suppose that a given link is incident to the nodes U and V. Each link is determined by 2 distinct nodes. It's easy to see that if we want the degree of the link, we could just add the degrees of the end nodes, except that we would count the link itself twice. So this gives us the equation kappa sub I is equal to k sub U plus k sub E minus 2. So we're using kappa for the link degree. And what we're saying is the link degree of link I is the sum of the degrees of the n vertices minus 2. So we said earlier that the link labeled F is of degree 6. And if we look at the 2 n vertices that define the link F and add their degrees, we would have 4 plus 4 minus 2. Now we're going to define the line graph of a graph. The line graph of a graph or a network is the new network that we obtain from the original one by representing each link as a node. And then in our new graph, given this set of nodes, the 2 nodes are adjacent if the corresponding links in the original graph are adjacent. So let's look at an example. Back to this graph, we like to use it for an example because all of the vertices and all of the links are labeled. So on the left, with our labeled graph, our links are labeled A, B, C, D, and E. So in a line graph, we'll represent each of these links with a node. So now we have nodes A, B, C, D, and E. We notice, for example, that link A is adjacent to links B and C in the original graph. So in the line graph, node A is now adjacent to nodes B and C. Notice we don't get the same graph because our line graph has a triangle. Our original graph did not. And in fact, in our line graph, the number of nodes corresponds to the number of links in the original graph. So one last observation, let's look at link C in the original graph. Link C is adjacent to links A, D, and E. So in the line graph, node C is adjacent to A, D, and E. And so in conclusion, we have talked about what we mean by the degree of a link, and that's the number of adjacencies for a link in the same way that we have the degree of a node, and that there's a natural relationship between the link adjacency and the node adjacency. And we've defined what we mean by the line graph of a network.